what's going on YouTube? We should be live now. Y'all, I am struggling today. I don't know what's going on. I'm super struggling. So I apologize, everybody, if somebody sees this at some point that I'm like 2 hours late or something today. Yeah, I had a hard time waking up today, and that's a little, that's a little not great. I feel it's we had friends over last night for a dinner party, and I guess I stayed up a little late, and I guess I'm getting too old to drink wine or something like that. So I just had a hard time waking up today. Not like properly hungover or anything like that, but just hard time waking up. Just had a hard time. So now we're awake, and I feel like it. I think I feel like still practicing calculus on the internet today. So let's do it, y'all. Let's do it. Let's practice calculus on the internet. We're multi-streaming again to Twitch, so that is a new fact. What's up, Ankur? How's it going, dude? How's it going? We got somebody in YouTube already. What was I just gonna do next? So I see that YouTube chat is working. We got one person. Hello, it's going good. Happy to hear that, dude. Happy to hear that. What else am I trying to set up? Let's see. I kind of want to confirm that we are correctly streaming to Twitch as well. Dashboard Twitch. I am live. Good. Okay, great. We are live. Great. Okay, cool. So this browser tab, I think I just keep in the background, and I just check every now and then. But then I have freaking chat up, and I have OBS up. Okay, cool. So anyways, I don't think this is the case, but if anybody is new and watching this, hello, welcome. My name is John. I am a enthusiast mathematician. I studied pure mathematics and graduated a long time ago, 2012. How many years ago was that? 14 years ago, I graduated with a math degree. And then I went into software, and I worked in Silicon Valley for the following 10 years. Working as an iOS engineer at big fancy companies like Apple, Lyft, and Google. I worked on iMessage at Apple, I worked on payments at Lyft, and I worked on YouTube and test infrastructure at Google. So nowadays, AI is just kind of evaporating my joy of coding, if I'm going to be completely honest with you all. It's on the one side, it's evaporating my love of working for others, but then on the other side, it's really supercharging my love of building and wanting to build as a solo developer. So over the last couple of years, I've been building as a solo founder a couple of apps and things. And I've started using social media to try to promote and share the things that I'm building. I have an app that's a time tracker for musicians called Mujo, and that you can download and try out. It's pretty nice little app. And then I've got another one regarding streaming music, streaming from music services, and a way to kind of unify like one kind of interface and one music player that plugs into multiple different streaming services. So think Spotify, Apple Music, YouTube Music, all of them. And then once you have a shared space like that, I think it'd be really cool to frickin' hell yeah, pro look. Hell yeah, dude. Thanks. What's up, Leroy? How's it going, bro? This project is on pause. It never actually shipped. I can't see you. Navit, is it because I'm on the side like this? Turn your phone. If you turn your phone, you get a horizontal. you get like a horizontal view, and then yeah, because I'm streaming horizontally, dude. Nice joke. We can see you. No, it depends on whether you're watching horizontally or on YouTube Shorts. Because in YouTube Shorts, they only see my hand right now because I'm like right off the center. Because YouTube is just a freaking dumpster fire, dude. Like YouTube is so bad in their execution of a good idea. Like vertical, like multi-streaming is such a good idea. It was like my favorite. It was like my number one feature request from YouTube, but there's no notice. Like they don't tell people that they can just turn their phone and then all of a sudden they can see the entire screen. That's crazy. That's crazy. So I'll go on rants about things like that sometimes because I work there and they laid off my entire team, so I'm a little salty about it. But yeah, anyways, so I've been a solo developer for a couple of years. Turns out that that's really quite hard. Nice shirt. Thanks, dude. Yeah, I feel like this could be a pretty cool standard shirt. Like, I've got a few sleeve shirts that I like that I'll wear a lot, I think. I think that I like this one a lot. Yeah. So I'm a little like hungover is a little bit of an overstatement. But we had friends over for like a celebration of a thing that's like just a little personal. But we were all celebrating a thing, and yeah, we had a bunch of wine, and I don't drink very much at all these days. I'm a fairly sober person nowadays, and yeah, I think I'm just getting like a little too old or a little too out of the habit of drinking alcohols. So this morning I just had a hard time waking up. I'm not hungover. I'm not like throwing up or anything. But this morning I was just like, I don't feel like it. I don't feel like waking up and getting on the internet. Don't drink. Yes, don't drink. Unless it's a special occasion. Yeah, so anyways, as you can tell, we're going to be drinking kills your gains. That is fucking true, dude. That is true. Drinking will kill your gains. What do you think drinking depletes? Do you think drinking depletes your math skill or not? Yeah, dude, I think it's part of the reason that I didn't do as well in undergrad as I could have. Bro, I drank way too much in college. Dude, drink a lot during the day. Do you mean drink a lot back in the day or during the day drink? Are you giving us an imperative, Leroy? Drink a lot during the day, every day. Like, that's like Snoop Dogg, like, smoke weed every day. Leroy over here is like, drink a lot during the day. Telling us all to drink every day. Okay, dude. I don't know about that. Anyways, where was I going with all this? So this is a math stream. I'm gonna be practicing mathematics. A drunk math stream would be funny. I don't think it would. Yeah, I party just a little too much during my day in college, and like I could have done better in my math classes, but I tried to do it all. I tried to be a social person, going to all the parties, as well as, you know, taking a crazy course load of graduate level math courses and stuff. You know, I could have done a little bit better. I think, if I didn't go to all the parties. But, you know, going to the parties was also fun. So, you win some, you lose some. I get Juneteenth off tomorrow, so I'm drinking today. Heck yeah, dude. Heck yeah. Alright, so today we're going to be practicing calculus some more. Where is my Apple Pencil? I don't feel like it. I mean, there's also another thing where, like, my wife had to get up earlier today for work, and so I kept sleeping, and then I didn't have to get up on the normal schedule. I don't know. It's a boring story, but it's not just having friends over and drinking. It's a little bit more than that. Anyways, who cares? Doesn't matter. Let's get the iPad on screen. I also took some extra time today since I was already so freaking late. I also took a little bit of extra time to just try to set up a couple of things. So now I'm streaming to Twitch, multi-streaming a little more easily. So I'm on Twitch and YouTube at the same time. You know, Pizza Hut and Taco Bell at the same time. And where is the browser chat? Oh, I hide this one. There we go. We've got chat. It's not yet interleaving Twitch and YouTube, but soon, soon. I believe in myself. I can figure that out. All right, so if we go back, I wish that there was a button I could click. I'm a keyboard-driven person, y'all, so using an iPad is very frustrating to me. Today, we are practicing calculus. We are practicing, more specifically, Chapter 1, Chapter 1 on limits from Taalman and Kohn. Today is not the 17th. Today is actually the 18th or 19th. What day is today? It's the 18th, yeah. So we've been doing this chapter 3 days in a row, for better or worse. I do want to continue and try to get further. So yesterday we did work through section 1.1, 1.2. We did a little bit of 1.3. Today I want to, just focus on 1.3, which is delta epsilon proofs. Pretty sure that we hit all of these. We got a thinking back, we got a concept problem, application, proof, and thinking forward. And those were our goals from yesterday's stream on that section. Then, what did we do yesterday regarding this next chapter? Not next section, not chapter. On the section for delta epsilon proofs, I believe that we solved one exercise. If I look at my book, which is the real source of truth for what we've done and what we haven't done, I've worked one thinking back exercise, and I've worked one skills exercise. So we made some progress yesterday. So today, I want to try to see if we can get a concept problem, applications, a proof, and a thinking forward problem. And I think that that'll be probably the entirety of today's stream. Hey, what's up, Lockheed? Very early today. You think that I'm early today? No, dude. No, I'm late as fuck today, dude. Do you mean that you joined the stream early within the time range of the stream? Yeah, you caught it at the beginning while I'm still introducing myself, and so I'm also ranting just longer because I'm like, I don't feel like doing math today. I don't feel like it. I'm a little hungover. What do you think of apostle calculus? I've done calculus, but not rigorously. Yeah, apostle calculus. Does apostle have two different calculus books? Because I took a upper division analysis course from Apostle. I wonder if he has two different apostle calculus books. I had like an advanced calculus, quote unquote, course. Mathematical Analysis, 2nd edition by Tom Apostle. I think that's the book that... Yeah. So, okay. I had an advanced calculus. I guess Apostle has two different books. One is calculus, like this book, And then another is advanced calculus, and now it's been renamed mathematical analysis. So I've never worked apostle calculus, so I can't say. I don't have any strong opinions, but it's not just 2 volumes. It's 2 different topics. Like mathematical analysis is kind of like what we're going to be talking about today, even though this is just, the very beginning, and it's just kind of the very beginning of analysis are delta epsilon proofs. So proof-based calculus, like theoretical, conceptual, proof calculus. Like this section is optional, according to Taalman and Kohn. So the star means that it's an optional section. Yeah. Identifying books in math is backwards because there's so many calculus books. It's like, what do you think of the calculus book? And it's like, well, which calculus book are you talking about? I think it's like that in a lot of textbooks, and a lot of books will do that. Or a lot of subjects. Like, I think people refer to the edition or something for classical guitar pieces, like, are you working from, for me, the Rogoznig or the Segovia for the Leyenda or something for Asturias? Are you working from Segovia or... Yeah, I don't know. Like, you refer to authors a lot in books. I think that's common, right? Okay. Anyways, let's zoom out. So I want to see if we can hit some concepts, applications, proofs, and thinking forward problems. So if I look at those problems from section 1. Not continuity. Continuity is the next section. Today, so yesterday we did this problem, finding the solution set of this inequality. And we did one skills problem. Like, we found using algebra delta that guarantees that epsilon equal 0.25 is guaranteed, that the function value is less than 0.5. The distance of the function value and the limit point is 0.25. So we did that skills problem. So thinking back, concepts, we haven't done one of these yet. And really, problem 0, every single concepts, exercise set, Taalman always has problem 0, read the damn section and make your own summary of the material. It's funny that she uses ink and space in every single exercise set. She uses space to repeat this exercise. Like, dude, don't forget to just take notes. Like, read the section and take notes. So we haven't done that yet, and I think it would only be right to do that today. So my summary, yes, math. Yes, math. There we go. Done. Problem 0 done. Let's move on. Okay, so we got skills, now applications. Then we're going to work this exercise. Suppose you work for so I'm very curious about this, applications of delta epsilon proofs. I'm curious about what this is going to be like as an exercise. Yesterday I came up with a pretty cool example of guaranteeing reliability of software services. Like, if you want to guarantee only 1% downtime, or 0.1% downtime, or 0.01% downtime, that is going to increase your engineering efforts and, cost your company money. And that's kind of like that's kind of like epsilon delta proofs. Like, I define a reliability or a tolerance, reliability / tolerance, tolerance for error, and then that, after I tell you the level of, downtime that we're allowed to have, then that determines, the engineering effort. / ultimately money. Because it costs more to guarantee that a system is going to be more or less reliable. Like something that's 80%, 87% reliable only costs $1. Something that's 90% reliable costs $2. Something that's 99% reliable costs you $3. Something that's 99.9% reliable is going to cost you $4, right? And on and on. You see the pattern. So this is like the number of nines. This is something that I would have swapped these columns, but who cares, whatever. Number of nines. We use this term all the time in software to talk about the reliability factor that we care about. So this first one has 0 nines at the beginning of it. The second one has 1 9. The third one has 2 nines. And then the fourth one has 3 nines. It starts with 3 nines, right? Okay. So I think that this is I honestly think that this is a pretty cool analogy to make and draw, because this is, a real world application of this idea, I feel. This can be maybe reliability or uptime. Yeah. Oh my gosh. Reliability / uptime. This is, which is essentially your epsilon. Your delta is your cost. And then another way to just reframe epsilon is the number of nines that are allowed. Yeah, never mind. I'm too lazy to think of tolerance money proofs properly. I love that term. Yeah. Thank you for helping me sharpen this even more. Tolerance money proofs. That's great. Tolerance money proofs. Similar to epsilon delta proofs. Okay. For all tolerance, there exists money such that for all downtime within tolerance implies money within oh, I see. Well, it's pretty close. Pretty dang close. For all tolerance levels, for all downtime, accepted downtime, there exists a cost that guarantees your service, is sufficiently reliable. Anyways, so I saw this here. You work for a company. Yeah, dude, I used to, and then the AI took my freaking job. Suppose you used to work for a money that manufactures gourmet soup cans. It's just like, dude, these like mathematicians are not like, why are we like doing gourmet soup cans? Like, I mean, that's cute. Like, mathematicians love to pretend that we're all, throwing baseballs around and, you know, just like doing soup cans. Like, this is a good example, I feel, or a good opportunity to talk about software and like an actual real world problem. Like, if you're gonna do applications problems, I want to see actual applications that sound useful in the real world. I really do. Like, if you are going to have applications problems. So not many people are dreaming of making soup cans. And like, I don't know, yeah. I feel like if you're gonna define applications problems and try to motivate a student, connecting math to the real world, you don't want to like try to connect, like, if you learn math, you can work in a factory, right? This is what this problem is. We're going to learn something about factory work. I think it would be a little bit better to be like, if you learn math, you can work at Google. I feel like that's going to be a little more motivating if you can give examples of finance or, tech companies or actual real world things, or like NASA. Like, if you're a, freaking philanthropist, or not a philanthropist, but like somebody who believes in the betterment of mankind, right? Like, I appreciate problems that are about advancing our scientific knowledge and things like that. I like respect those, I guess. But when a mathematician gives application problems about something kind of silly, like calculating how many squirrels are in your attic and other things, it feels a little tongue-in-cheek, like a little like derisive, I think, of applications. A little bit. Suppose you work at Google. Suppose your boss asks you to calculate the number of gourmet soup cans such that... There you go. Thank you. Yeah, now we fixed it. Suppose you work for... let's cross this out. For Google. And your boss... tasked you with manufacturing gourmet soup cans. Done. Fixed. Suppose you work for Google and your boss tasked you with manufacturing gourmet soup cans. The material for the curved sides of the cans cost 0.25 cents. Okay, now I can stay focused on this because it's going to make me money if I understand this problem. The material for the curved sides of the cans costs 0.25 cents, a quarter of a cent per square inch. Okay, so we've got a cylinder. These are gourmet soup cans. Yum. And when, the material that you curve around into a cylinder is 0.25 cents per square inch. And then the top and bottom, like the lids or something, are 0.5 cents per square inch. So at the top and bottom of this thing, we've got another type of material that's 0.5 cents per square inch. And the reinforcing weld around the seams costs 0.1 cent per linear inch. Oh, cool. Dang. Okay. So there's a weld. And it's not in the drawing, if I understand correctly. Oh shit. No, it's here. It's here. Okay, so this... Oh, this is a cool application. All right, so it's only around one of the height edges, and it is around... Yeah, I see it. So the top blue line here is connecting to that top, like welding around this to the lid. And then there's one spot somewhere. I don't know if that's what this oval is meant to represent somehow. But somewhere around this dang cylinder, there needs to be a weld line where we weld, right? So that's the blue lines in this soup can cylinder correspond to the blue lines here. So notice it's on 3 of the sides of that rectangle. Okay, neat. And this costs 0.1 cents per linear inch. The seams run around the edges of the top and bottom and also in a straight line from the top to the bottom of the curved side. Okay, so that's exactly what I was imagining. Find a formula for the cost of producing a gourmet soup can with radius R and height 5 inches and answer the following. Yeah, linear inch is a term I've never seen. It's like saying one-dimensional length. I love it, though. I mean, yeah. Like per inch. Usually they'll just say per inch. But it is kind of cool to just really contrast. Like, I think that's just to, like, really contrast square inch versus linear inch. Like, remember that these are, you know, for every square inch, there's, you know, so many square inches in this dang thing. But then along this side, there's, you know, so many linear inches. I know that you know what that is, but I just want to show that for anybody else, maybe. Okay. So let's, I think now I've got enough understanding of this to clip it out, and let's try to... Dude, we don't need this anymore. Let's just take all of this. Beep. I mean, I love my little drawings around the soup can stuff and whatnot, but whatever. Let's just lose it. It's still out there on YouTube. And Twitch, even though nobody's watching Twitch, of course. Because if I copy while there's handwriting on top of the page, then Notability is only copying the handwriting instead of copying the PDF, clipping from the PDF. So that's why I'm just going to take a shortcut here. All right, so this is section 1.3, delta epsilon proofs. It's an optional section. This is crazy to me. Everybody else in the world calls them epsilon delta, but Taalman calls them delta epsilon proofs. I guess delta is the x-axis and epsilon is the y-axis, but epsilon provides delta. Like, epsilon implies delta, so it's crazy to me to call it that way. There goes the epic Google motivation. I know, there it goes. We can redo that part. That doesn't take very long. Suppose you work for Google, like I used to, for YouTube. And your job is manufacturing gourmet soup cans. There we go, done. The material for that, blah, 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 blah. We got all that. Find a formula for the cost, C of R, of producing a gourmet soup can with radius R and height 5 inches, and answer the following questions. Okay, so let's get started writing that down. solution. We want to find the cost of a soup can. Okay, and a defined height. I'm going to curry this function. Because I was going to say, well, the cost is going to depend, like a tiny little friggin' like cat food. Cat food is like a short cylinder with the same radius versus, I don't know, like a tennis ball container has a different height, and that's going to cost a different amount, right? This might be a reliability cost proof. It might be. I haven't ended up reading it, but that would be super cool. Yeah, I literally, anything I haven't said out loud, I haven't yet read on this problem. So you all might have already paused the video and read the rest of it, or, read it with your eyes while I'm, yapping. So we're just going to assume that h is 5, and we're going to call this C of r for simplicity, assuming that h is 5. So this is like occurring. I took a function that requires 2 variables, and I fixed one of them. Or it's really more of a partial application of a function, but whatever, who cares? C of r, let's see how much can I do just on my own? So the radius, we're assuming that it's always 5 inches tall, maybe like a potato chip or soup. Why would soup cans require 5-inch high? It just seems odd. Like I would. Well, whatever. Yeah, who cares? Okay. So we've got the cost of the area of the edge. What do you call it? The curved sides. We've got the cost of the area of the curved sides plus the cost of I want to call them lids, but that's not quite the right term. Oh, yeah. They call it the top and bottom. So I could say top and bottom, but let's simplify to lids. Plus the cost of the welding. Okay? Now the area of the curved sides, the cost of the area of the curved sides is 0.25 cents per square inch times, so we're talking about the area of the curved sides of. Are they calling it sides? Yeah, the material for the curved sides of the cans. I mean, it's really one side, right? Like, it's just like one side or like one curved material around. So I'm a little hesitant. I don't know. The cost of the lids is 0.5 cents per square inch. So 0.5 cents per square inch. So we're talking about the area of the lids. And notice that there's 2 lids. So we could go ahead and call that 2 times 0.5, or just leave that to the next step. And then the cost of welding. So the cost of welding costs 0.1 cent per linear inch. Okay, so plus, what was it? 0.1 times, this one's a little interesting. It's like the 3/4, it's like the partial perimeter of the rectangle, of the rectangular side. So I'm going to give these literally names like this for now. And you don't see math books writing out individual steps like this, but this is how we do it actually in programming all the time. Like you define a function named area, or you define a function named partial perimeter of rectangle. And I think that we should start introducing those sorts of ideas so that you get the concept before you translate to the mathematical, proofs. Like, this helps you think through, I think, it helps you think through the concepts and write down those concepts as you go, I feel. So the area of the side, we're talking about the area of that rectangle. So that's going to be 0.25 times, well, the area of the rectangle, notice that the height is 5, and the radius, so remember that this top line here corresponds to going all the way around this circle. So going all the way around the circle is the perimeter of this circle. And the perimeter of... Oh, wait, shoot. No, I started switching over to this thing. But we do need to know that side length of this rectangle. And we can get it by... So in other words, the rectangle is going to be a width of, let's call it W or X. I like X and Y so that we clearly say horizontal versus vertical directions. So I'm going to try to erase this gently. Nope, that's not going to work. There we go. I'm going to call it X. I like X and Y because that reminds me horizontal direction versus vertical direction. We never forget that. Regret studying math? Nope. Love it. Love it, dude. Love studying math, personally. The height is fixed to 5 inches. Yeah. Curved surface area, lateral surface area. I wonder when K will be back. Me too, dude. What the hell, dude? If he has to restart to a new channel, I would just probably not do it. I'd switch to Twitch if I were him. Or just, I don't know. I don't want to say that he should give up because that's bullshit. He should not give up. But if he has to restart, that would be horrible. Because it's a grind. It's a grind to get to monetization, which he's gotten to. It's a grind to, especially if you're doing live streaming content, because all the monetization thresholds, all of those criterion is really optimized for videos. As a live streamer, Like, dude, that would be a shame. Like, I hope that Google can see, like, that he like files appeals or something, or like files like for help from customer service or whatever, like from like the help center, and that they can just see obviously his account was hacked, and that's not on him. I feel like, dude, I don't know. Like, I hope he can reinstate his account, because that would be messed up. The circular portion is called the base. Yeah, base is great. Yeah, I don't use Twitter personally at all. Any regrets studying math? None at all. Mine is focusing too much on contest high school math because of its prestige instead of head starting on actual higher math. Sag. Yeah, I mean, I never got into contest math. I never got into competition math myself. So I don't have that experience. I kind of did the bare minimum, planning to do engineering. I plan to be an engineer someday. And I, self-studied and taught myself calculus over the summer before taking AP calculus. But I didn't get started learning higher math until college. I would say my only regret, which may be kind of like what you're saying, but a little different, is that I regret not being exposed to higher math or pretentiously real math until college. Like, I wish that I had been exposed to the idea of like pure math during high school years, where you have like a lot of free time and your life is just full of hobbies and just, having fun and studying stuff just because it's fun and geeky and everything. Like, because you just don't have as much time, like, while you're, while you have a full course load and you're trying to pay tuition and everything. Yeah, so it's similar to you, like, but it's just that for me, I didn't get serious about math until college. For you, you were serious about math with computational contest problems. But like competition problems do train like real mathematical thinking. Like, were you doing like the IMO problems, or like, because I wish that personally, my regret is that I didn't start looking into IMO or, the art of problem solving books, all of that type of math. Like, I wish I had seen. I was doing Japanese math Olympiad stuff. I don't know what that is. I mean, this is Olympiad, and it's international, so I think that you might have been doing the IMO. I never got into that. So I still to this date have never, looked into it at all. So I'm only imagining what it would be like, honestly. Because I know that it doesn't do the theory building of higher math, which is, you get to more interesting questions, I feel, once you can start talking about groups and things. I didn't do these, but I did do the Putnam in university. And I'm proud of it. I freaking did the Putnam twice. I think I got a 2 out of 100 one year. And then the next year, I believe it was a 7 or an 8. I think it was a 7 out of 100. And like, for those who don't know, I was celebrating for getting a 7 on an exam. Like, I hope that like Leroy is still in the chat, somebody who like doesn't know math and has probably never heard of this exam. Like, this is one of my stories that I like to give people when I like try to convey that mathematicians love math because it's hard. like, there's something beautiful about just the fact that math is freaking hard for everybody at some point. Like, for everybody, math is hard at some point. And in university, we have a competition where the average or median score is like a 2. Like, I think that this is like the median score. So I was right in the middle. Some years it's a 2, some years it's a 0. Sometimes the median score is a 0. Like, most people got a 0 on this exam. Like, it's crazy. You know, it's just so funny. Like, I love it. But that's what you enjoy about those. Like, so I think that if you didn't have experience being exposed to pure math and proof-based math and math competitions, then you're not going to be one of the people scoring higher scores on the Putnam. Like, the only way that you can do well on the Putnam is if you were exposed to pure math and already self-studying or studying with a mentor, pure math during high school. Yeah, I mean, I don't know. What are your thoughts, Zafar? Have you taken the Putnam? You're in undergrad, right? Have you taken the Putnam yet? You should. I think you should. It'll put some hair on your chest, you know? It'll really put some hair on your chest. It's fun. I loved it. And I was very proud to get a 7. That means that you, like, had the idea on a problem. You had the idea, but you weren't able to, like, precisely write it down. As I understand it, the Putnam, you can, on a problem, typically you can get like a 0, 1, 7, 8, 9, or 10. Like, they typically don't give any scores between 1 and 7. For a single Putnam problem. Oh, you're not in America, so you can't take the Putnam, but you've seen the question papers. Yeah, I can't solve anything, lol. Yeah. It's gnarly, dude. It's very gnarly. So, yeah, being in an exam room for 6 hours and just like, well, I already signed up for this. I got no other option than to try my hardest on these questions. Like, if you want to, you can do that yourself, just simulate it, but you have to force yourself to sit down for 3 hours to try to take the first half, take a break, then 3 hours for the second half, and you're not allowed to leave. Like, just try your hardest to try to make any amount of progress on one of those problems. It's crazy. I enjoyed it. It's like not the worst way to spend a Saturday during undergrad, I feel. But yeah, like, we're so used to grade inflation. Like, everybody should get a 90 and above on a class or on a paper. So being proud of a 7 was awesome. Like, I don't know. I like that. I like that it's unforgiving about it's a hard-ass exam. And you should not feel bad if you got a 0. A lot of other people got a 0. A lot of smart people. They're, like, generally only smart people who are good at math are taking the Putnam. And the fact that most people get a 0, 1, or a 2 is, you know, it's just humbling in a good way. Okay, so we've got some progress here. The area of the side length is going to be x times y for the way that I wrote the rectangle, and y is fixed to being 5, right? So I'm going to rewrite this now as 5/4 x. because 0.25 is the same as 1/4, right? That sounds fun. It was fun, dude. Like, it really was. I'm glad that you're here for that. It was cool. Yeah, you're just stuck in a room, 3 hours for problems 1 through 5. You take a short break, and then you get 3 hours for problems 6 through 10. And they're just like insanely hard. Why did I get a 7? I think that 7 is like, it's really just like correct idea, partial progress, like you made some partial progress on the correct idea or something. Like, I guess a 1 is something like close to correct idea. I think. Or possibly correct idea, but no progress. Like in pure math, you often say like claim XYZ and then proof if ... So this, I don't know, because I never really dug into the precise scoring, like, and it's just unclear. They don't like publish a rubric or anything as far as I'm aware. I think that if you just make the right claim or something that looks like the right claim, that like a claim that's close to the right idea, then you get a point. And if you make some amount of progress on the proof, then if you had the right idea and some amount of progress on the proof, then you get a 7 on that problem. Yeah, 1 is a foundation and 7 includes some work, but it's not complete. I think that's it. I mean, it's possible that I got 7 different correct ideas and no partial proof. I don't think so. Probably not. But yeah, very fun. Very fun exam. Very hard. Like, just intentionally one of the hardest exams ever. Okay, so the area of the lids, well, that's pretty relatively straightforward. The area of a circle is pi r squared, and r is our variable. Like, we know for sure that r is not fixed. And multiplying by something by 0.5 is the same as dividing by 2. So, but here's that gotcha. There are 2 lids. So maybe it would have been better to make that clear here. So there are 2 lids, so there should be 2 of these guys. So now I'm going to write this as pi r squared. 1/2 times 2 is 1. Then we have 1/10 of the partial perimeter of the rectangle. And by that I mean 2x plus y. The partial perimeter is all 3 of these blue lines added together. Partial perimeter then would be 2x plus y, and then multiplied by 0.1 is the same as dividing by 10. And we know that y is fixed in the way that we've formulated this. So if we want, we could try to tidy this up just a little bit. Let's collect the x terms. if I split apart this fraction, that would be x over 5. So there I've collected the x terms. Let's collect all of the terms using r as a variable. Well, there's only the one, pi r squared. And then let's collect all of the constant terms. So if I split this apart, this fraction, then 5/10 is the same as 1/2. Okay, now I've simplified. Is it just me or is it lagging? Is it my video? Is my audio lagging, or just the iPad? Sometimes the iPad lags if I have this application in the background. So it should be better now. How about now? Is it any better, or is everything lagging? So now we know that this is a free variable, that r is a free variable. So, and that there must be a way to deduce x. And so I'm going to kind of pause this work for a moment and say that x, let's find x. And as I said before, x is the perimeter of this circle. So notice that the blue line, the horizontal length of this rectangle, is the same as the perimeter of the circle. The perimeter of the circle and the perimeter of a circle is given by 2 pi r. And r is a free variable. Right? So I paused my previous work to get this. And now let's resume. I wish I used a different color for some stuff, but whatever. So now 5/4 plus 1/5 is so 5/4 is the same as 25/20. So 25 plus 4/20 is 29/20. You can convert all these to decimals if you want to be lame about it, but x is, now I know what x is, 2 pi r. Pi r squared plus 1/2. Now, 29 pi r divided by 10 plus pi r squared plus 1/2. I don't know if it's much better, but we could factor out a pi r. So then we have 29/10, which 29/10 is a little nicer and fully precise to write as 2.9, right? And if I factor out pi r, then factoring out pi r out of pi r squared leaves r, plus, if I change one thing to a decimal, I want to change the other one to a decimal, just in terms of, seems like all the signals, oh wait, okay, everything is lagging, including my video and audio is lagging too. Is it any better now? Audio has been fine, but the others are rough for me. Okay, shoot. Yeah, my, let's see, still pretty bad. I see encoding overloaded. Consider turning down video settings or using a faster encoding preset. Let's see. How's my disk space? Are we swapping already? Let's see. Is it still pretty bad? No, I've got plenty of disk space. Let me close a couple of applications. I've got a beefy computer, so I'm surprised anytime that we're taxing it beyond. My CPU's at 23%. I guess specifically just for OBS. It might be that I'm multi-streaming now because I'm on Twitch and YouTube at the same time. Pizza Hut and Taco Bell. It has not resolved itself, huh? Is it still bad? I'm on Ethernet now, and I've got a beefy internet connection, so I get confused when this happens. Like, why would this be happening? Ooh, exercise for the abstract algebra guys. Figure out characteristics of rings where this derivation would break. Nice. Yeah. Yeah, I don't want to scare the undergrads, but yeah, shoot. I see Twitch also is saying unstable connection too. I'm gonna have to figure it out over time. I don't know what to tell you all right now. Just let me know if it's like unusable, if I should just stop Twitch. Because I think that's what we would do. We would just stop Twitch and keep YouTube going. Is stream frozen? That's my question, maybe? Is it? Dang. Might need to stop Twitch. Oh, I don't feel like doing math today. I don't feel like it. I mean, I do and I don't. On my end it is, although my internet is also bad right now since I'm in a car. Might be a combo of those. Other people are also completely frozen. No audio, etc. Audio, but frozen face cam. Yeah, audio's there, but video is bad. Yeah, I think it's an encoding overloaded. Consider turning down video settings or using a faster encoding preset. Okay. I'm gonna stop a recording because I'm also recording locally. I wonder if that... I mean, that's not really necessary. I don't really... Those videos just frickin' devour my disk. And it probably taxes the encoding even further. I mean, right now the iPad is not moving. The iPad sometimes is lagging. I guess I will blame my internet then, but other people are also having issues, so it really might be me, dude. And Stucky, if you're still there on Twitch, please let me know. Okay. So now I think that I have a formula that I can work with that only uses R. So I believe if I did every step along the way correctly, that now we have a cost formula. So, that's step one. I dropped my Apple Pencil. Let me find it. Okay, so I see that my local recording has stopped, and I wonder if that is going to improve the situation. It may or it may not. Streaming is hard. I see for a moment my upload dropped to like 900 kilobits per second. Sometimes that just happens and I don't understand why. But now it's back to 3600, 3700, 3900, 2900, 4600. This has become jcpractices reading numbers. Stuttering. Okay, you're getting stuttering too. In the camera, not just the iPad. Stuttering in the audio also. The lag is crazy. Shit. Okay. All right, Twitch is... We're going to turn off Twitch. Okay. What about now? We'll see if it gets any better. I was a bit behind. Looks a bit more fine now. Okay. Oh, dang. All right, well, I just turned off Twitch. If anything, it should just get better now. If I need to, I might use a service called Restream, which will be one upload connection, and then they multi-stream for you. So it requires less upload resources on your end, but the downside is that it has much higher latency with chat. So, and that's a pretty big downside to me. Like, yeah, there's higher latency, so I can't, like, converse with you all in real time as quickly. And that's if Twitch is worth it, which I, for myself, feel like I need to start diversifying to Twitch. I don't know, dude. Anyways, let me know if it's better now. Right now, it is currently... Right now, this is my best way to make sure we're all in sync. At the moment, it is 12:58 p.m. Eastern Time. Yep, it's still 12:58 p.m. So, if you see this point of the video and it's 1:15, then you're behind. Okay, so now I have my cost function only depending on the radius. Okay. So, in retrospect, we could have found x first if you felt motivated to do that first. Could have done that first and then started everything in terms of r. I wonder if one can define it's smooth now. Yeah, it probably was multi-streaming then. Damn. I used to be able to multi-stream pretty well. I'll have to think about it. I'll have to think about how to fix that. The solution might be Restream, but then again, Restream requires more latency. It's smooth now. It could be RAM. I don't think it's RAM, actually. My computer's got some beefy RAM. And I don't see... Well, Figma was open this whole time. And I do have Chrome open. I don't typically use Chrome. Oh well. Maybe we ended the party early for Twitch unnecessarily. I don't know. We'll see. We'll try again tomorrow. We'll figure things out. Oh well. Alright. So, we're back. So I think that's something that they asked for. What is the radius of a can that is 5 inches tall and costs 30 cents to produce? Okay, so yeah. First, find a formula for the cost C of R of producing a gourmet soup can with radius R and height 5 inches, and answer the following questions. So we've done this part. And now part A, it's kind of rude, I feel, for the author to be like, oh, this is just preliminary. That should be part A. But oh well. This was like preliminary, like part 0. Part 0, find the cost. Then it says, find R such that the cost is 30 cents. And let's double check that our units still lined up correctly. The units everywhere, yeah, these were 0.5 cents per square inch. So everywhere where I was using like 0.5, this was in cents. So the numbers still line up correctly. Then we solve this. 2.9 plus R times pi R plus 0.5 equals 30. Okay, so now I'm going to unfold this back to this quadratic form. Pi R squared. Okay, so there's two solutions here. If you are an engineer, you could just plug in some numbers and then find out using binary search, just figure out like a number relatively quickly by just punching in some numbers into this formula. Because sometimes the equations that you're solving can only be solved numerically. And it might be faster to just guess and check. But if you're a mathematician working on exercise from a nicely written Calculus 1 book, this is something that we can solve using the quadratic equation, because we have one variable. Remember that pi is just a number. We can use that everywhere. We have one variable with a quadratic, with second degree. Really, we're solving it like a second degree polynomial or a second degree equation. Yeah. 2.9 pi R plus 0.5 minus 30. So minus 29.5 equals 0. Now, this format of the equation can be solved using quadratic equation. The quadratic equation gives us R equals, let's sing it together. Negative b plus and minus the square root of b squared 2.9 pi squared, b squared minus 4ac all over 2a. Okay. This is a negative number, right? So, and all of this inside the radical is going to be a positive number, right? So the square root of a positive number is a real number. Like, we're not getting complex solutions. No, we don't have I anywhere in this. So then the square root of a positive number is a positive number. Now we have an equation that's in the format of like plus, this is a little cursed, but a positive number plus, or wait, no, sorry. Oops. A negative number plus or minus a positive number divided by a positive number, right? And we're talking about cost. Or no. Sorry, we're solving for a radius. Remember, so this must be a positive number to work in our three-dimensional universe. So we can throw out, the negative solution. We only care about solving negative 2.9 pi plus that square root. So this is negative, and now we can ask ChatGPT. And we can really test its abilities. 2.9 times pi squared plus 4 pi times 29.5. We get 400. At this point, I'm okay, dipping down to decimals. I like 2 decimal places, generally speaking. Divided by, my calculator can handle pi perfectly well, so I'm going to keep that. Now, I'll take the square root of this number. $29.30 if I keep 2 sig figs, divided by 2 pi. And now this is 1.94. I could start using like little approximate signs, approximately equal signs, to remind myself that I did lose some accuracy exactly at this line. So if I ever need to go back and double check my work or something, I have strict equality here, but then I dip down to an approximation at this point. But this probably is good. This is almost, I feel very good that that's close enough. The radius is going to be approximately 1.94 inches in order for the cost to be 30 cents per can. It would be funny to raid Topos Institute after this, since they're doing a talk live stream right now. Dude, nobody knows that you can turn on raiding, though, on YouTube. Nobody knows about it. Nobody knows. Let me try, dude. I would love to raid other YouTube live streamers. You don't get it. The reason I'm on YouTube as a live streamer is because I wanted to help build live streaming for YouTube. I wanted to be a product manager building the live streaming platform. I don't know if you all get it. This whole stream, both this stream and the guitar practice stream, were me trying to understand the ins and outs of YouTube as a live streaming platform so that I could get a better job, because AI is going to devour engineering someday. And so I've been studying and trying to understand YouTube as a live streaming platform from the very beginning, and there's just so many damn problems with it. So I bet Topos Institute. Yep. They are live, but redirect privileges needed. Ask Topos Institute to add you to their live redirect list in community settings. See? Like, it would be fantastic to raid Topos Institute, but they either have not turned on raiding or redirecting. What a goddamn terrible name, dude. Like, either they haven't turned on redirecting at all, or they turned on subscribers only, or like, you know, an allow list. Like, redirecting has been built on YouTube prioritizing allow listing as opposed to block listing. And bro, that's just such a bad decision. Whoever is a product manager that decided that they need to be fired, dude. Like, whoever decided when they launched redirecting in 2022 while I was still working there, whoever decided that redirecting requires 1,000 subscribers and is built on allow lists as opposed to block lists, they need to be fired, because redirecting is most valuable, and it is literally the definition of a viral feature for a social media app, because the more people, like, it's a viral thing. Like, once one person does it, then the other person learns how to do it, and then they start rating multiple people, and then each of them learn how to use it, and then each of them start rating multiple people. But then for small streamers, it's more important than for anybody else. Like, once you have 1,000 subscribers, you don't even have the desire to rate as much. But when you're a small streamer, you want to connect and meet every other streamer. So when you have one subscriber, rating is so much more valuable, just to network and meet other streamers and build a little network. It's like just the definition of a viral feature, and they just fumbled on so many different dimensions. The name is horrible. It sounds like an engineer put in a placeholder name. Live redirect was like the engineering term, and then they never got around to finding a real name for the thing. That sounds exactly like engineering placeholder name that made it into production. Horrible name. After party. Call it an after party. I was trying to tell people that while I worked there. Call it an after party. Like, this is the main show. This is the party. And then this is the after party. I recommend you all go to this after party. It's going to be awesome. Like, if you want to keep partying after this party, go over there and go watch them. Like, dude, that would be such a good name. And it just kind of can tie to, like, rock concerts and music. Like, YouTube has music as an entire product line, you know. YouTube Music as its own entire product line. Twitch is built around gaming and branded around video games. YouTube is where normal people are who like to party and who like to listen to music. Like, branded around live music concerts. Like, and they did that. They did do that in the fall of last year. They announced their biggest freaking updates to the live streaming platform, and they branded it all around the idea of, like, imagine you're at a rock concert. Imagine you're at a concert and you hold up a sign and the band looks at you and they recognize your sign, and that just for that brief moment you have a connection with your favorite band. That's what live streaming feels like. Yeah. Brand everything around concerts. Like, and get giant bands to run live concerts on YouTube Live. Like, dude, it's just sitting right there for YouTube to win live streaming for the vast majority of people who don't play video games, you know, are international. Everybody listens to music. Like, oh my God, dude. Like, it's just sitting right there, and they're just fumbling every step along the way. Sorry. Apologies. Should I buy a tablet for study/note-taking? I think so. I think the tablet is a good idea. But personally, honestly, I don't think it's that much better than just paper. Paper and a paper book and a paper notebook is your best friend. It's the best, most productive system. It is the most productive system. But if you ever want to share or teach somebody else, bro, an iPad is amazing. Like, especially, I'm biased, but I do think that the Apple iPad with the Apple Pencil is still by far the best experience for a tablet. If your Google boss wanted a negative radius, did you discuss that with them first? Yeah, that sounds like an entire paragraph in a real design doc. That, like, decisions, alternatives considered. We could allow negative radius soup cans, but we decided against this because that is difficult to achieve in the real world. And while it is a beautiful mathematical, it keeps the theory simple and it keeps the engineering simpler to achieve, it is less useful to the end user. Therefore, we decided against negative radiuses. That would be a point of bike shedding in the technical design document review. Anyways, there's our periodic rant from John about how bad live streaming is on YouTube and how good it could be. How much potential there is in this freaking platform, man. Like, there's so much potential in live streaming for YouTube. My paper math notes are disorganized between 38,000 notebooks. That is another very good reason to prefer digital. If you're still here, if I haven't scared you off. The Meyer Beher, great name. Nice to meet you. I've lost all of my old paper notebooks. Paper notebooks are more productive in the moment, I think, for sure. Digital notebooks are more productive in the future if you ever need to reread it. You can, like, Command F and find your LaTeX, solutions from the past. But then, most of the time, you don't ever go back. You never need to go back and reread your old notes. So I'm on the side of paper if it's just purely self-study. Now, if you're writing a thesis, if you're actually doing real work, real original work, you have to use digital. So, but if you're talking about for studying / note-taking, I think paper is your best friend. Like, that sounds to me like you're just talking about solving homework exercises. Anyways, this is a long bit. I meant to do proofs. This section is on proofs, and I ended up just like, I don't feel like it or something. Your manager wants you to produce 5-inch tall cans that cost between 20 and 40 cents. Okay, here we go. Now we're finally getting to writing a requirement as an absolute value inequality. Hell yeah. So now we're introducing tolerances, and I was curious about, manager says, your EM says, I don't care exactly how much it costs. It just needs to cost between 20 and 40, okay? Anywhere between 20 and 40 is fine. Just get it done. We don't need to nitpick on the exact cost of the thing. Now we're going to solve when is C of R greater than 20 and when is C of R less than 40. We're solving two different inequalities now. Yeah, I mean, there's just an endless argument. There's pros and cons so much to digital versus paper. There's no good single solution, I feel. Okay, so where... So I kind of lost the 30 in this point, but if I want to refactor my previous solution, this was negative 30 plus 0.5. That's how I got to negative 29.5. So then this also can be rebuilt as negative cost plus 0.5. And so we would solve the inequality for negative, well, let's lose the negative sign because now we've already combined the negative with the negative in the quadratic formula. So we can replace that as cost minus 0.5. This was negative cost plus 0.5. And so we would solve this entire quadratic equation again with 20 minus 0.5, i.e. 19.5, and 40 minus 0.5, which is 39.5. So the cost needs to be let's make sure we got this correct. So the minimum cost is 20. Yeah, so this is when cost is 20, and then the other one is when cost is 40. Right, so then everything else is pretty much exactly the same. So let's see. We can come back to this previous work that we've solved before. And get 19.5 on the one side. Oops. I'm writing this like a little freaking sort of messy, or like not cleaning up earlier for a reason right now. Like, I think that we could have made this a little bit more elegant, but here's like a very direct way to write this. So the radius of the can needs to be greater than this number, and it needs to be less than this other number, right? Well, we're going to clean this up a lot if we multiply the entire inequality by 2 pi. Negative 2.9 pi plus the square root of, I'm going to, yeah, let's just keep it. 2.9 pi squared plus 4 pi times 19.5. We can get an exact number on that. 19.5 doubled is 39, right? And then doubling 39 is 78. So this is 78 pi. This needs to be less than 2 pi r And 2 pi r needs to be less than negative 2.9 pi plus the square root of 2.9 pi quantity squared plus 4. I wanted to refactor this to a single line, so I'm going to cheat by just moving it. Try to do that on a physical chalkboard. Ha ha. All right. If I quadruple 39.5, 79, and then 79 doubled is 158, right? Let's ask ChatGPT on that one. Pretty sure that's right. 158, got it. $158 pi. So what I did was I multiplied the whole equation by 2 pi, and I just simplified I simplified the decimal times 4. Now we can clean this up a little further. Um, 2.9 squared, I kind of want to do 29 times 29 divided by 100. But whatever, let's just keep it. 2.9 pi squared plus 78 pi needs to be less than 2 pi r plus 2.9 pi. So if I add 2.9 pi to both inequalities, then that cleans up this equation a whole lot. 2.9 pi squared plus 158 pi. I mean, I suppose I wanted actually a equation with what range of radii would satisfy your manager? Okay, shoot. 5-inch tall cans that cost between 20 and 40 cents. Write this requirement as an absolute value inequality. I think I'm just kind of jumping ahead already. So 20 needs to be less than C of R less than 40. Yeah, I kind of just jumped ahead to solving. I'm already doing part D. Here's a fact. If A is less than B, is it true that A squared is less than B squared? Well, -1 is less than 0, but 1 squared is greater than 0. So it's not true, at least if A is negative. So what about and A is greater than 0? What if they're both positive? Yeah, I think that's true. There's no edge cases like if A is between 0 and 1, A squared would shrink even further. Yeah. Then, as long as they're both positive numbers, which all numbers in this inequality are positive, I think I can square the entire equation. 2.9 pi squared plus 78 pi less than 2 pi r plus... We're coming back to the quadratic equation again. I'm just kind of going in a circle right now. It's best to just solve these numbers, honestly. I already have... Yeah, what am I doing, really? Just freaking get these numbers here. Yeah, I'm going in circles. What am I doing? Negative 2.9 times pi. Okay, my calculator does not allow brackets, unfortunately. Negative 2.9 times pi plus the square root of 2.9 times pi quantity squared plus 4 times pi times 20 minus 0.5. Am I missing a parenthesis somewhere? That one binds to that one. That one, I am missing one parenthesis. Divide by 2 times pi. So this left-hand side is 1.43. It's approximately 1.43 inches. And this right-hand side, recognizing that I'm doing a little bit of rounding in a couple places, or in one place. This right-hand side is approximately equal to 2.38 inches. So, yeah, let's scratch out all this. We didn't need this direction. So, all radiuses for the soup can between 1.43 to 2.38 all satisfy that the cost is between 20 cents and 40 cents. And this is our solution. Yo, what's up? Gibran, sir, what standard is this maths for? This is calculus for high school or calculus. Or for high school or undergraduate math. Yeah. What's up? How's it going, Gibran? How are you? All right, so that took a while, but we finally got through an applications problem. And I suppose this is literally a cost-effort type of... It's similar to cost versus something. We're finding the cost, like an allowed amount of cost of producing a can of soup, like the cans for a can of soup, and the radiuses of those cans that satisfy cost. So, hey, kind of similar to the example I was making up about software. I'm good. I'm doing good, dude. I'm doing good. I'm streaming mathematics for fun and because someday I want to become a high school math teacher, like an awesome, overpowered high school math teacher. Oh, you're in grade 10. Well, let's go, dude. You could learn calculus with us, bro. You absolutely could. So I am studying... Right now, today we're doing calculus. But I'm studying 3 subjects. I'm studying 3 different difficulty levels of math or something. High school, college, and graduate level. Or grad school. I think that's a better way to say it. Grad school. So right now we're still in high school math, and I think that you could learn calculus with us if you wanted. Right now we're in chapter 1 on limits, and we've been focusing on section 3. This is an optional section, learning about the formal definition of a limit and writing proofs about limits. But I've done other streams on section 1, section 2, intuitive limits, formal definitions of limits, and then previously I also run streams on functions and pre-calculus. So I bet that some of these words might seem familiar. So I also run streams in chapter 0, which is like preliminary material. Hell yeah, dude. Check them out. I hope you enjoy. I'm trying to practice math every single day here. Just to build the habit of studying math every day for fun. For fun and for profit. So, yeah, you've done some pre-calc. Nice, dude, nice. So I bet you've learned some of these ideas, like how to graph a function, the inverse of a function, transforming a function, like shifting a function graph up and down, or like reflecting a function across an axis. Algebraic functions, those are pretty cool as well. Exponential and trig functions, those probably sound familiar, most likely. And then this last one is a optional section on kind of intro to proofs, mathematical thinking, logic and mathematical thinking. Yeah, nice, dude. Nice to meet you. We've been doing a lot of limit streams, and I want to start moving on to continuity in the future. Let's take a couple of notes. Let's do a little bit of note-taking on this formal definition of a limit, or delta epsilon proofs, so I can say that we did it. Describing limits with absolute value inequalities. Okay, so this is cool. In the previous section, we formally defined a limit. The previous definition of a limit has a very geometric flavor, they say. The geometric definition says that limit as x approaches c of f of x equals L if there exists, if for all epsilon greater than 0, there exists a delta greater than 0 such that if x is in this punctured interval, so c minus delta to c union c to c plus delta, then f of x, the function value, is within this interval, L minus epsilon to L plus epsilon. So this is like the geometric flavor definition of a limit. But now, Taalman, this is really cool, to her credit, I haven't read this till now. She does define it with the algebraic definition of a limit. The algebraic formal definition of a limit. She says the limit lim as x tends to c, f of x equals L, means that for all epsilon greater than 0, there exists a delta greater than 0 such that if 0 is between x minus c, the absolute value of x minus c is greater than 0 and less than delta, then the distance between f of x and the limit value is less than epsilon. So this is another equivalent definition. So she says the previous definition has a very geometric flavor since it's stated in the language of epsilon intervals and punctured delta intervals. That kind of language is useful when looking at specific values of epsilon or delta, but not as useful when trying to prove that every value of epsilon has a corresponding value of delta. For the purposes of proving limit statements, we give the following algebraic definition of limit and prove that it is equivalent to our previous geometric definition. So here's our definition of the algebraic definition of limit, and then a theorem proves that the two are equivalent. Yep. Neat. Okay, so she has like a whole proof. Yep. Makes sense. That's an awesome hobby instead of doom scrolling. Yeah, and I want you all to watch this instead of doom scrolling. Is this not the same definition? You and I are both thinking like, well, this is trivially clear that they're equivalent, but like, dude, here's where I'm trying to say, like, I'm not going to write it out because it's not really that valuable to slowly write this out for me. Again, because I want to teach high school and I don't have to prove everything as carefully as I wish I would need to. But like, she has this boxed as an algebraic definition and then a theorem that the two are equivalent. The two definitions of limit in definition 1.5 and 1.10 are equivalent. Specifically, part A, the x being in that punctured delta interval is true if and only if the absolute value statement is true. And then part B, f of x being in the f of x being near L is true if and only if the absolute value version is true. Proof. We will begin by proving part B since it is slightly easier. The statement f of x is in that means, so the definition of that interval inequality says that L minus epsilon is less than f of x and f of x is less than L plus epsilon. subtracting L from all three parts of this double inequality, we get this. This is precisely the solution of this inequality. Yeah, I mean, true. You do need to show that. I mean, they seem like it's tautologically equivalent or something, but that's not true. We're using some mathematical intuition that you and I have to say, like, yeah, just algebraically showing that a geometric statement regarding points being in an interval is equivalent to, like, why are these absolute value, requirements true or something. For part A, we have a similar situation, except that we must deal with a punctured interval. The statement x being in this means that x is between these and x is not equal to c. Yeah, that makes sense because x is in this union. So another way to write this is like x is in c minus delta, comma, c plus delta, minus the point C or something. Like, the union of those, or x is in that and x is not equal to C or something. Okay, so subtracting C from all three parts of the double inequality, we get this. From the double inequality, yeah, which is the solution set for the inequality this. The fact that x is not C means that x minus C is not 0. This is equivalent to saying that the distance of x and c is not equal to 0 because of the property of the absolute value distance function. Like, absolute value of a minus b is greater than or equal to 0, and it's only equal to 0 when a and b are the same. Or this absolute value of x minus c equals 0 if and only if x and c are the same. But since we know that they're not equal, then, yeah. Since the absolute value of a number is always positive or 0, it is also equivalent to saying that x minus c, absolute value of x minus c is greater than 0. Therefore, x is in this interval if and only if that. I think that that's a nice proof for like a high school calculus, like introduction to calculus, like to have this carefully written out and not just one, but two formal definitions of the limit and proving that they're equivalent. This is like a level of mathematical reasoning that I did not experience only taking AP Calculus. True algebraic would be via category theory. Okay, according to you. John, what are your thoughts on Mamdani wanting to teach high schoolers Arabic numerals and ancient Arabic methods such as algebra to high schoolers? Yeah, I'm all for it. I think that Arabic numerals are better than, the Latin or, Roman numerals. Yeah, I'm all for algebraic numerals. I know that Mamdani can ruffle some feathers, but I'm all for it. Arabic numerals are pretty awesome, and they are superior. They help us calculate things like the Fibonacci numbers better. Finding a delta for every epsilon. With our new algebraic definition of the limit, we have the final tool we need to be able to effectively prove limit statements. This is the first step towards being able to calculate limits. She really emphasizes the difference between calculating and proving, something that, perhaps surprisingly, we do not yet know how to do. Consider, for example, the limit statement this. We can examine this limit with a table of values. So, yeah, if you build a table of values, we can see that the function values, the bottom row, is getting close to 5. We can also investigate the limit statement with the following graph of f of x, noticing that a sequence of values of x approaching x equal 2 from either the left or right determines the sequence of values of f of x that approach y equal 5. So this is showing the geometric graphs of the epsilon delta definition of a limit, like the geometric intuition. We can even show that the formal geometric definition of limit holds for a particular epsilon by finding some delta guarantees that. For example, if we play this game and I define epsilon as 1, then you can find delta being 1/3. As illustrated in the middle situation. So in this, delta or epsilon is 1, and then we can find the right delta being 1/3 to guarantee that 5 plus 1 and 5 minus 1, the function values are always between those, between 5 minus 1 and 5 plus 1, whenever x is between 2 minus 1/3 and 2 plus 1/3. But then if you decrease the tolerance, then 5 plus 1/2, if our tolerance is only 1/2, plus or minus 1/2, then our corresponding precision, required precision or something, becomes, what does it turn out to be? But we're finding these by, we're finding these by solving the function values at these corners, like when does the graph of the function cross these two horizontal lines, to find those 2 points, and then that determines, those 2 points determine these corresponding this corresponding input interval, the delta interval. And it turns out that delta can be 1/6. So this is 2 plus 1/6 and 2 minus 1/6. Okay, cool. Although the preceding investigations are encouraging evidence, none of them prove. This is evidence, these are like examples, but they don't prove that the limit is equal to 5. Yeah, the 3 graphs shown each have the same possible problems. To prove that the limit is 5, we would need to know for certain that we could get values of f arbitrarily close to 5 by choosing values of x that are sufficiently close to 2. For every epsilon, we would need to be able to find a delta. Like, it's not enough to just say, okay, I showed epsilon equal 1, then I can find a delta. Dang it. Epsilon equal 0.5, then we can find a delta. No, we need to find for any epsilon, no matter how unimaginably small, like it can be unimaginably small, like it's impossible to even write down how small it is. It's that small. like 1 divided by a Google is still not small enough. But for any epsilon, for all of them, that we can always find a delta. Specifically in this example, we need to show that for any choice of epsilon greater than 0, we can find some delta greater than 0 whenever a real number satisfies this. We also guarantee this. So if you can convert the game is kind of to try to convert f of x minus L less than epsilon. If you assume this, then you want to try to convert that to this inequality. And then you can also just, at the end, also add a requirement that 0 is this. But this part is not hard. You can always just add that as an extra requirement after. Like, the hard part is to find the right delta. So this f of x minus L is not in the form of x minus c in general. So in the example that they're giving, I'm going to try to work it myself without reading their answer. The function value is 3x minus 1, and the point that we're considering is 5. When x is 5, we want to show that when x is 5, is that, wait. Oh, no. The limit value is 5 when x is 2. Yeah, when is the function value close to 5? We want to try to transform this somehow to this, to finding absolute value of x minus 2 less than delta. So, well, if we assume this first part, then we have 3x minus 6 is less than epsilon. And then from there, I can factor out, it's a property of the absolute value that you can factor out a common factor. Now this is in the format that we're looking for. X minus 2, if I divide the inequality by 3. Epsilon over 3. Now it's in exactly the right format. Take delta being epsilon over 3. Then our algebraic definition of the limit is satisfied. Okay, cool. This is super cool. So this was actually the problem that we had an exercise in the previous section that was working this exact same example, which is kind of neat, actually. Delta epsilon proofs. We've just proved that limit of as x tends to 2 of 3x minus 1 is 5, but our proof meandered about in a paragraph of discussion. We now present a systematic way to write up delta epsilon proofs for limit statements. Remember that in our example, what we must show is the following doubly quantified logical implication. For all epsilon greater than 0, there exists a delta greater than 0, such that blah, blah, blah. Logically, to prove such a statement, we must first let epsilon be an arbitrary positive number, then choose a value of delta in terms of epsilon. We must then show that for all values of x satisfying that, then that. In our example, we already know that for any epsilon greater than 0, we should choose delta being epsilon over 3. Using this fact, we could arrange our proof very concisely as follows. Given epsilon greater than 0, choose delta being that. For all x with this, we have blah, 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 blah. Therefore, whenever 0, we also have this. The first three equal signs in this proof are simple algebra. The less than step followed from our assumption. So the less than step is right here, followed from our assumption that x minus 2 is less than delta. Yeah. The start inequality followed from the fact that delta we chose to be epsilon over 3. Yep. In general, we will not know at the outset what to choose for delta, as we did just now. In those cases, we can either do a side calculation, which is what I'm very used to doing. Like, you do a side calculation to figure it out, and then you write your proof carefully. To find delta in advance, or just leave a blank space for delta and continue with the proof. When we get to the starred equality, after using that assumption, we will be able to see what to choose for delta, and we can fill in the blank as if we knew it all along. See example 2. Throughout the examples, we will try our hand at proving all kinds of limit statements, including one-sided limits, infinite limits, and limits at infinity. Cool. Let me try to work. Well, let's see. How much do we have? Any more main theory, or is it all examples from henceforth? Yeah, it's just examples for the rest of the section. Cool. So I feel good at this point about wrapping up this stream at any point, like very soon. We've done the concept problem. I've read the section, and even if it's just taking notes within the book itself, I'm taking notes, and I'm trying to actively read this section right now. So I'm pretty close to calling the first exercise, which says read the section and take notes. We're close to being done for that. 5 formulas for delta in terms of epsilon for each of the following statements. All right, so let's try to work this example on our own before I read the solution and see how close I get to it. So, epsilon greater than 0 and f of x, which is 2x plus 1 minus the limit value 9 is less than epsilon. Then we know that 2x minus 8 is less than epsilon. Then 2 times x minus 4 is less than epsilon. Then x minus 4 has to be less than epsilon over 2. I think, and yes, as I expected, this is now in the format of x minus c less than delta. So now I've found my correct delta. So I carefully write now the proof. Let epsilon be greater than 0. Then delta being equal to epsilon over 2 guarantees so how do we do it? F of x minus L. Oh wait, no, oops. I got it backwards. I claim that this satisfies that implies f of x minus L is less than epsilon. So let x be a number such that 0 is less than x minus our 0.4. And delta is epsilon over 2. Then 2 times x minus 4 is less than epsilon. So 2x minus 8 is less than epsilon. And finally, there's something, this is 2 times, what is the format again that I'm looking? 2x plus 1. So that's adding 2 to minus 10. Therefore, this now satisfies the fact that the limit as x approaches, when x approaches 4, of 2x plus 2, 2x plus 1. Oh, wait. 2x plus 1. Oops. 2x plus 1 minus 9. I messed up a little bit. The function value is 2x plus 1. So minus 8 needs to become minus 9 plus 1. Therefore, the limit as x approaches 4 of 2x plus 1 is 9. Hey, what's up? I don't know how to pronounce your name, but nice to meet you, dude. How can I refer to you? Do you have a nickname or anything? Nice to meet you, dude. Or if you want to tell me how to phonetically pronounce. Okay, so we got something close. The limit statement, that means that given any epsilon greater than 0, there's some delta greater than 0, so that if this, then we can conclude that we have 2x plus 1 minus 9 is 2x minus 8. So, yeah, right now we're doing the scratch work, the side calculation, which is exactly like what I did. We did the side calculation to find delta equal 2. In particular, when epsilon is 1, we have that, and punctured delta interval. Okay. Well. Oh, okay. This only said find formulas for delta. It didn't say write the proof that limit as x tends to 4 of that function is 9. So I went kind of to the next step. This question was only asking find delta in terms of epsilon, then use those formulas to find delta intervals when epsilon is 1 and when epsilon is 0.5. So then, yeah, we just have 4 minus delta to 4 union 4 to 4 plus delta. And then we just take epsilon being 1, we get, when epsilon is 1, we get 3.5 to 4 union 4 to 4.5. And when epsilon is 0.5, we find something smaller, something similar. We find 3.75 and 4.25. Okay, so we got that. Okay. Yon Si-un. Nice to meet you, man. Nice to meet you. Yon Si-un. Thanks, man. I appreciate it. I find it very important for me to be able to learn how to pronounce everybody's names. I think that that's a very important thing to nail, you know? All right, thank you. Okay, so we did this example. I'm going to mark it in the book so I know that we've worked this one. These examples, you should try to work them on your own before you read the solutions. That's something that took me some time for me to learn and really understand. Okay. Now, writing basic delta epsilon proofs. This is the same example. It's just that, from the previous example, we found delta should be epsilon over 2, and then the proof that I already worked was given epsilon greater than 0, choose delta being epsilon over 2. For all x with 0 less than... For all x with a distance to 4 being less than epsilon, less than delta, we have this, is this, is this. It's the exact same computation that I did. It's just kind of weird that, it makes sense. We get the inequality because x minus 4, absolute value of x minus 4 is less than delta. And then we have this star, it's an interesting star equal, but this is equal to 2 times epsilon over 2, and that is equal to epsilon. Therefore, whenever that, we also have that, QED. Cool. If we had not already known that we should choose delta being that, we could have determined that choice when we reached the start equality. At that point, we had shown that was less than 2 delta. Okay. Yeah. Awesome. So I got that. And this is a nice feature in these, even in these exercises or even in these examples. She really marks in a... Dude, this is such a good book. I love this book. And she even includes the little, you know, she includes a little cute square. This is another way to write QED. QED, some mathematicians will use QED, meaning therefore it has been demonstrated, quo ero demonstratum, or something like that. And then other mathematicians like to draw a cute little square. I like the square, personally. So, even in these exercises or these examples, whenever she's asking for a proof, when your exercise is a proof, then it's like boxed in a nice little yellow box. Everything has been inverted color, so it doesn't look as nice for you, but for me, I see that it's a nice little yellow box, you know, yellow indented section, and, you know, the lovely word proof at the beginning. Cool. Proofs for one-sided and infinite limits, and it's going to be super similar. It's just that the one-sided delta neighborhood, the delta neighborhood is just a one-sided interval, not a two-sided punctured interval. So other than just a bit of extra work to translate this, it's a standard delta epsilon proof. So hell yeah, dude. Example 4, a delta epsilon proof where it is necessary to bound delta from above. Why is this one more interesting? Let's try to figure this one out. I just studied solving normal limits questions. Well, this is the real limits questions. And I hope that you try to understand a little bit about it, because this is where real math, we talk about limits in terms of these epsilon delta definitions. Okay, so we want to show that that the absolute value of the function value minus 80 is less than epsilon given 0 less than absolute value of x minus 2 is less than delta. So 5x to the fourth minus 80 implies that x to the fourth minus, so if I factor out a 5, this is 16. If I factor out a 5 and then divide by 5, we get this inequality. Now, how can I try to get to x minus 2 from there? Well, from this one, x to the fourth minus 16. Let's do a polynomial division somewhere. X to the fourth minus 16 divided by x minus 2. we can do this with synthetic division. 1 cubic squared constant. I know that 2 is a 0 of this, because 2 to the 4th is 16. But what's the remainder after I divide by x minus 2? So the root is 2. 2 times 1, add those numbers. Add those numbers. 2 times 4. Oh, wait. What? Wait. To the 4th cubed squared. I'm missing 1. X, the linear x term, the 1 degree term. Yeah, I was missing a column. 2 times 4 is 8. Oops. 0 plus 8 is 8. 2 times 8 is 16. That's 0. So then, therefore, this polynomial division is x cubed plus 2x squared plus 4x plus 8. Does that help? I mean, another way to do this one, which was my first thought, would be x squared plus 4 times x squared minus 4. And this is probably a little bit better. X squared plus 4 times x plus 2 times x minus 2. Because now I actually factored 2 parts. Okay, anyways, like, it's x to the 4th minus 16 can factor as x minus 2 times some other terms. X minus 2 times this polynomial. X cubed plus 2x squared plus 4x plus 8. So if how do I do these freaking proofs? Well, I'm going to read the solution on this. No, I haven't heard about the Sunung question paper. Thank you for asking. I haven't heard of that one. Let me write that down. So just a bit correction, say it's she, not C. Okay, C. If you don't mind, because I would have a hard time pronouncing that. I'm gonna write you down as Yeon Shi Un. Oh wait, no, she. I should write it. Shi Un. Thanks, dude. Look up the Sunung question paper. Heck yeah. I'll look at that. Thanks. Okay, so to prove this, we blah, 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 blah. Algebra has always magically worked out nicely. Yeah, this is where delta epsilon proofs can just epsilon delta, not delta epsilon. Epsilon delta proofs. Sometimes they're just really convenient, and sometimes you just have to be clever and find the right argument. In this example, there will be a point at which we get stuck. I think that's where I am. What will get us out of the jam will be assuming that delta is no larger than 1. Oh, okay. This assumption will allow us to put a bound on an expression that would otherwise be in our way. For that reason, our choice of delta in this proof will be the minimum of 1 and an expression that depends on epsilon. Clever. Okay. Oh, shoot. Okay, well, how do we find epsilon over 325, though? Okay, the reason for this elaborate choice of delta will be made clear at the two starred inequalities that follow. If x is a real number with that, then... Okay, so I got to this point. I just wrote it the other way. I mean, either way, I got there. Okay, yes, I should have also used the fact that absolute value of AB always equals the absolute value of A times the absolute value of B. So you can split. I should have gotten to this point, but I didn't. My bad. And then this has to be less than 5 delta times this other thing. Okay. Yeah, I should have gotten there. Because our choice of delta ensures that delta is at most 1. And we have this troublesome quantity. It's largest when x is 3. So this quantity is largest. You can... How do we know that How do we know that the maximum of x plus 2 times x squared plus 4 is 3? How do we know that? X squared plus 4 I mean, is this even true? Wait, I mean, it must be, but okay, when I thought that... What? Oh, on some interval. Okay. Yeah, because this monotonically keeps increasing at some point. So, I mean, this is some cubic function, but then the fact that we are bounding delta to be at most 1, then we're only going to look at the interval with between 2 minus 1 and 2 plus 1. And that function keeps increasing, so at the right side of that interval, then the maximum of this on the interval of 1 to 3 is 3, or the maximum is 3 plus 2 times the maximum is when x is equal to 3, and then the maximum is 9 plus 4, 13. And now this is 65. Random number. But that builds the fact that this must be less than 5 delta times 65. Because again, we previously got to an inequality of 5 delta times the absolute value of this troublesome cubic. And this is less than or equal to 5 delta times 65. My delta and 6 look super similar, so I apologize for that. I see. Okay, so then we get there, and then 5 times 65 gets us 325 delta. And then this is less than or equal to... I thought delta... I thought delta is epsilon over 325. So I don't know why we have a less than equal... Oh, because delta is the minimum of these two. Okay, yeah. Delta is the minimum because we took an assumption that like a neighborhood with length 1 might be enough. Oh, this is super cool. Yeah. Then we can conclude that. Yeah, dude, that's awesome. That was a trickier one for sure. I don't know if my analysis ever got to the point where I would have been able to get that on my own. I mean, it did. It's just that the proofs that you do in actual analysis courses are a little different. We're not working so many specific examples of functions. You work more conceptual problems. Okay, well, I think we got it. Nice. Thanks for watching, everybody. I gotta go. Please do like and subscribe, and if you know anybody who might enjoy a really nerdy math stream like this, please do share it with them. I mean, live streams become even more fun when you know more people in the chat. So, bro, I just came. That's gross. What's up, dude? Jadugar, how are you? Sorry that you missed it, but I've been going for almost 3 hours, so I'm sorry that you missed it. You can always rewind and watch some if you want. So thanks for watching. I just practiced calculus for 3 hours as an adult for free without being paid because I am a nerd and I just want to relearn math. Are you fine now? Yes, I'm doing fine. Are you asking? Yeah, I was super late to stream today. I had friends over last night and I went to bed late and I had a couple of glasses of wine, and apparently I'm getting old and I can't even have 2 glasses of wine without feeling kind of crappy in the next morning. So yeah, I woke up and I was just like, I don't feel like waking up today. I don't feel like it. But then eventually we just got up and we did the thing. Practiced math on the internet. Thanks for watching. Bye. Bye, everyone. I gotta go. Bye. Thanks for watching. Bye. Oh, join the Discord. Last shout out. Join the Discord. And if you want to help me grow as an artist, here's a couple shout outs. Discord, link in the description, or jcpractices, discord.jcpractices.com. That's one CTA. Also, just fun fact, all of the music that we've been listening to today, dude, all of the music in the background is me. So follow my guitar channel at jcpractices guitar. If you want to help me grow as an as a musician, as an artist, as a mathematician, as a YouTube creator. Check it out. I think that, honestly, I think that you'd like it. It's a very similar practice stream. It's all built around the idea of practicing live and showcasing how I practice stuff like music. Yeah, I could play you a song real quick, but hey, how about this? I'll play you a song live right now, but if you like it, you have to subscribe to my guitar channel, okay? Jadugar, Lux, I need you both to say, to promise me, if you like the song, then you'll subscribe. He doesn't play sad guitar songs. I don't. No, I only play happy guitar songs because I've got enough sadness in the rest of my life. No, I do play some sad guitar songs, but not lately, not recently. Hey, do you need revisions in math? I don't know. What do you mean by that? Already did, but still, I would love to hear. Okay, heck yeah. Yeah, dude, you've already subscribed? Hell yeah. And Lux promises it. Hell yeah, we got one person who has agreed to play my game. All right, if anybody out there is not yet subscribed and you enjoy this guitar piece, then you are tasked, you're supposed to, on honor code, I hope to see you in a guitar stream sometime. Thanks for watching. What do I want to play to finish this stream today? Let's do... Okay, what can I do? I'll do this. All right, just big old picture. What do I want to play? These are all my channel supporters on my guitar channel. So they're totally harmless. They don't hurt the guitar. They're like static cling. People always kind of wonder. It's always the first question when people see the guitar for the first time. So I get ahead of it and I just answer that to begin. Okay, you all, do you want Bach? Some like beautiful old Bach Baroque music? Or do you want something more modern, like a kind of more like a rock song? I could give you something that's like a little more like a rock song. I do classical guitar, so it's not rock music, but a little more upbeat. Yeah, did the guitar consent to these tattoos? Nope. Something to relax your nerves. Let's do it, dude. I'm gonna give you some Bach then. This piece is called Prelude for the Lute by Johann Sebastian Bach, BWV 999. Yeah, the other one would not be very relaxing, I feel. Not as relaxing. Cool. I hope you enjoy it. I hope you all enjoyed that. Thank you. Thank you for listening. It's an honor to be able to play for you all, like that. It's math and guitar are my two passions, in this life right now. And I do practice guitar and study math for fun without being paid. Like, I'm getting paid a tiny amount, but I'm overall losing money on guitar. Like, math and guitar to me are just equally as beautiful. Math and classical music, really, but all music in general. So thank you for listening to that. I hope you enjoyed it. Dude, you rocked, bro. Thanks. Thank you. If you want to hear more of my music, I think that the best place would be either my recitals playlist. I can link to that right now if you want to go listen to some more classical guitar to fall asleep to. Or my RCM 8 EP. So, same thing, rcm8.jcpractices.com. Either one of these would be pretty good. This one is available on Spotify as an EP. Available on Spotify, etc. Everywhere, all of them. So let me give you a couple of links here. Recitals.jcpractices.com. I recently ran a recital in January. In April. Yeah, more recent. Holy crap, it's already June, isn't it? Or this one, which was a full EP of recordings. So thank you. I hope you enjoyed. And if you want to watch more math, of course, there's a lot of math in my channel. I'm studying calculus, linear algebra, and representation theory. So, dude, good luck, Jadugar. I hope that you try my my recitals or my guitar music. I think for some people it's pretty good study music, actually. Like, I really do think it might be able to help you if you want to go listen. Thanks for watching. Bye. Bye, everyone. Appreciate you all. Thanks for watching. Bye. Yeah, I was a Swift engineer. Yes. I still code. I mean, I still build indie apps, but I'm no longer working for big companies. For anybody who's new, I worked at Apple. Then I worked at Lyft, the taxi company. Then I worked at Google. In fact, I worked at YouTube at Google. And now I'm indie. I work for myself now. And I want to become a high school math teacher. So I'm on a journey right now to becoming a high school math teacher. Haven't made it yet, but hopefully soon. Do you use LeetCode? No, I ran those interviews for other people who are doing LeetCode. I used to use LeetCode, but not anymore. Now I run those interviews. I'm not Indian, no. I was born in America, but my parents were born in Colombia, South America. So I'm Colombian, at least most recently, yeah, in my heritage. So thanks for watching. Colombian American, I guess. Thanks for watching. I hope you all have an awesome, awesome rest of your day. Thanks for watching. Bye. Bye. Oh, your name's Harsh. Okay, cool. I graduated from Oklahoma State University. And I graduated with a bachelor's in pure math. Yep. Take care. Bye.